Hi, I'm Jonathan Stevens from Everypoint, and today I'm going to jump into NeRFs. I'm really excited about this share. I hope a few people are able to make it to this live. My plan was to make this more informal, not a long presentation about my findings with slides, because I'll have slides just to keep me focused on what I'm supposed to be talking about, but no one wants to sit and watch slides on NeRFs. Everyone wants to see it in action. And so today I have been exploring NVIDIA's Instant NGP, or their neural graphics primitives, and they have instant NeRFs. And we've all seen the shares on YouTube going around on LinkedIn of these instant NeRFs, how they're trained in 6 seconds. So I was really curious. I decided to jump in and see what I can learn from it. Um, from here, I'm just gonna basically launch my desktop and run through it. Now, a few tips: it is very GPU heavy, so if you don't have an Nvidia GPU with CUDA cores, you can't really do this yourself. You'll need one of those. Also, I have an RTX 3080. That makes it faster for training, but it also has a cap on the amount of RAM I have, the video RAM, because it's not using my CPU RAM, which I have lots of. So as you go through this, you might find that things crash. I can basically provide some tips on how to get it not to crash by taking less RAM, but we'll dive into that. So let me just share my screen here so we can get into the fun part. Let's see here. All right. So I just have this page here to kind of keep me on track. I'm going to go through install tips, and this is very easy. I thought this was going to be a lot harder to build, and I did run into quite a few little headaches. So I'm going to tell you what I did that helped, but also I'm going to show you basically how I did it without actually doing it, because no one wants to sit here for an hour for me just to build this project to show it off. So the first thing I have here is basically a fork from NVIDIA's Instant NGP GitHub repo. So if you go to the actual repo, they have lots of great information. And they actually have how to install it. So you don't have to do it yourself. You're not trying to figure this all out yourself. However, someone else, by Cloud AI, had went and did a fork on the GitHub repo and broke it down in a really cool video as well. So I can actually open that up as well. He's got this great video. I suggest following along. He actually has Patreon members. I'd say jump on that if you want to follow his other work and support him. But along with that, it's pretty easy. And as I went through here, he basically addressed most of the gotchas. So if you look in this and you watch his video, you'll see most of those gotchas. I just had a few tips that he kind of glossed over because things just worked for him. So let me just jump back to my slides here. Um, so I found that I had to reinstall Visual Studio 2019. You can use the community version. I had to reinstall CUDA Toolkit. I actually had proper version. For some reason, I had to reinstall both to get it to work. And they say you can just upgrade CUDA Toolkit. There's things you can do to fix these. Just reinstall it. I also had Python 3.10 on my computer. I quickly removed that when I realized that was causing issues. Even when I told CMake, don't use Python 3.10, some reason it was using it. So I'm not a compiler wizard. I am actually not a coder. So I just know how to use this stuff enough to build it. And I assume you could too. So message me outside of this if you need some help. So I also found that you needed CMake 3.22. I believe they have 3.3 out. Again, it'll tell you that you can't use that version. So just don't take the extra effort of installing the latest version. Install and deprecated this older 3.22 version. So from there, just follow his instructions. It's pretty darn easy. You're going to install Visual Studio. You're going to need Anaconda. It says use Optic 7.3 or higher. If you go to that, it's also going to ask you to basically sign up for a developer account. Go do it. It's not a big deal. You get a lot of emails from NVIDIA after that, but it does speed things up supposedly. And just follow these instructions. They're actually fairly straightforward as you go through this. And I see one of the comments, what kind of animal is this? I think there is I don't know, a wolf head. I don't know. That's one of the samples that they have. So just go through here. They actually have some sample data sets you can use. This is my first NeRF as well, was this guy. Okay, so let's jump into some of the more exciting parts. So when you take photos, I found out that it's using what's called map in the background to estimate where your photos were taken. That way, you can kind of figure out how to trace light through each of the camera images in the scene and build this great looking NeRF. And because it's using map, they're using structure from motion, you need to follow the best practices that you would do for photogrammetry. And if photogrammetry is new to you, I'm just going to break it down really simple for you. You want to make sure everything's clear and focused as possible. You can take video, but I found that video is going to have some blurriness unless it's really bright out or you have a really good camera. On your even on your iPhone, when you're moving, things get blurry. So if you can, just take some stills and walk around. And I always like to think of it this way: you take a photo, you're just going to move a little bit, take another photo, and keep that camera just kind of pointed in at one common feature as you get through there a scene. You can walk all the way around an object. You can walk kind of around the top, making a dome, getting full coverage. Just make sure you got lots of overlap between each photo. You can also just take photos from one side. So as I start to show these NeRFs here in a few minutes, I'm just going to show you where my camera poses are because NVIDIA gives you great visualization tools to see that as well. Um, so yeah, let's go over how to prepare those photos really quick here. So that's pretty easy. So what you're gonna do is take photos. I have an iPhone. This is a Windows machine. You have to do it on Windows, obviously, with an NVIDIA GPU. So I basically just had to, and you don't have to use Windows. You can use Ubuntu, but I basically put it onto my desktop and then copied it to a folder. So when you build your whole project, you'll have this instant NGP folder where you have all your data, and it will be dumped into this data folder. And from here, you just basically dump them all into one job. You're gonna put it in this. If you follow the instructions that they have, you're just gonna put it in the data and then a folder for that specific image set. And then here's your photos. So just jumping through here, this was actually a DJI Action 2 camera that I had photos of the stump, and you can see there's a lot of overlap between each photo. I see a lot of the same features on that stump. I didn't get too crazy. Actually, took this last fall, I believe. Just happened to be, oh, let's test out a data set I already had. But I got to see the whole entirety of this stump, which I really liked. And I thought, let's try it with kind of a warped camera. There you go. And you can see this is not the most clear photo. I may have dropped that one if you wanted to. Once you got those in there, you're going to start training those, and that's pretty easy. So you'll follow the instructions, and you're gonna launch Anaconda prompt, and then from here, you just need to do a few things. They give you the scripts on the GitHub page, and as a little trick, I just copied out my modified version of those scripts. So first thing you do is change your directory. So I just changed my directory over to that instant NGP folder, and then you're gonna have to activate NGP with Conda, and that's just making a little virtualized environment where this all runs. And then you have to run what's called map. In the instructions, it's pretty easy. This will be basically a Python script it calls, and you're going to put it in like that, and it's going to say Python scripts map to NeRF. And so if I go to instant NGP, I have a scripts folder with some Python scripts they gave me, and this is going to run map and create a file that the NeRF training needs. And so from there, you just pick your images and the path. So for me, it would just be uh, data slash stump for this one, and then hit enter and it runs. I would run it on my machine. I'm afraid that it's going to take a long time with all this. I'd find that if you're training a data set of about 99 photos or less, it only takes me on this machine less than 10 minutes. It's not very long. Oops. So once it's done training, you end up with a transform file. Um, put one down on my computer here. Looks like this transform.json. And you're just going to put that in your images folder. and it tells you a bunch of information about each photo. So you have basically the name of the file, the sharpness. This is important because you can actually go and remove ones that aren't sharp if you want. Um, you want sharper photos. And you go through here, and it basically is telling you where that camera is in this 3D space. And you don't really need to jump into this file unless you're doing some troubleshooting, which I'm going to show you at the end here how it can really help to know how to modify just a couple of these variables. So after that, you're going to jump that into one of your folders. I'm going to show off a bridge that I captured yesterday. So you can see here, there's transforms.json. I put it in here. Then you're actually going to create another data folder and then another folder called the first folder. So you see data, bridge, and there's my bridge images. So let's look at this image set I took. I literally walked around this bridge with my iPhone, snapping photos. I made sure I wasn't moving when I took each photo to be as still as possible. I hopped the creek, made my way around. I get to the other side again. I hop the creek, my best to get the angles I could. And then I wanted to see the inside of this, inside of that. So from here, oh, I was taking some more top down, trying to get reflections. But from there, I was getting the inside of one, inside of the other, and that'll get you just more information because you want to look at things not at a high angle, you want to look at them straight on. And that was it. That's basically the image set. So not complicated. You can just circle things. All right. And someone asked if I'm able to record. I believe I'm recording this. If I'm not, I'm gonna have to redo this, but that's fine. No. I'm recording this in StreamYard, and LinkedIn should put this out later to watch as well. So that's a good question. And hopefully, I'm not going too fast. I think the more exciting part is getting into NeRFs, but just give you an idea of how these photos look. Just circle it, taking a bunch of photos. Uh, Another tip: these photos ended up being 12 megapixels. I had 99 of them. I ran out of GPU memory, so I actually took these and downsampled them to 6 megapixels. I use Photoshop. You can use FFmpeg, which you install anyways with this. There's a bunch of ways. Just look up online how to downscale bulk images. It's pretty darn easy. In fact, I think there's websites you can just upload your data to. It spits out. Okay, so now let's start up our first NeRF. So I'm going to go back to this Anaconda prompt here. Oops, that's command line to Anaconda. And instead of preparing my images, I'm just going to now launch the exe that I built with CMake and then point it towards basically this folder of images and it'll start training. So this is where it gets a little bit more exciting. All right. So I'm just going to pull up my handy dandy Notepad++, which I may have accidentally turned off. So let's hear Notepad++. Here we go. Here's my scripts. Again, I always say I could have turned these into some sort of automated thing, but just for playing around, I just copy and paste the scripts. So I have one render ngp nerf. So I'm just going to copy paste that in. So what I'm doing basically is finding this testbed.exe, which I built in my builds folder. So if you want to do this manually, I'll just show that to you as well. It might make it easier for people if you don't have a script. But you basically go to your NGP folder. You're going to go to your build folder, which is here. You're going to find this testbed.exe. Just drag it straight into this Anaconda command prompt window. Then I'm going to hit -- scene and data / and then I'm going to do the bridge. So bridge. And that's all you have to do to start this up. And someone also asked, has this session been recorded for YouTube? I will be posting this on YouTube as well. If you are following me on LinkedIn, you can watch on LinkedIn, but also have it on YouTube later, probably later today. So here we go. Hit launch. Hopefully it doesn't crash my computer or crash the instance because I'm also live streaming. So as it's doing right now, it's just training the position. So it looks fuzzy and you can see this bridge starting to come into focus. The top here, I hope everyone can see it's big enough. This is how much memory I'm taking, 3.85. I actually downsampled. So again, at twice the resolution, it was taking of the images, it was taking more than 10 gigs of RAM. So just know that you can downsample images as an easy way to do a data set without crashing a lower level GPU. And a lot of people said they had 1080 or some sort of GPU with only 8 gigs or 6 gigs of RAM. So this one will be well under 10 gigs. All right. So what's happening basically is it's doing neural network training. I am again, I put in the notes for this show. I'm not an expert on NeRFs. I'm actually really good at just figuring out how things work on an application level and seeing what they do. But if I just let this train, it'll start to sharpen, and there is a diminishing return. So after about 2 minutes, according to the documentation, it's about as good as it's going to get. You're not going to see any improvements after 2 minutes. So that's kind of helpful. So I'm just going to let it keep running, and you can see it sharpening, and it's pretty neat. They give you this whole entire GUI on the left here. You just expand this, and from here you get all kinds of great parameters that you can look into. So you can stop the training once you're happy with the results, which is great. Because then my frame rate's 5. That'll jump up because it's no longer having to use my GPU to train the data. It's just has it sitting and rendered. Uh, you can pick what you want it to train on. So right now it's training encoding and training the network. Uh, I'm not exactly sure what all these do to improve the scene. I found that training exposure can help if the scene exposure seems off. So if I just click that on, it'll start training that. And you'll see that this loss graph will spike back up if you pick something that takes a lot of its power to run. So there we go. They give you some other things to training the milliseconds, a bunch of parameters that I'm not a developer, so I'm not exactly sure what they're doing. All I know is that this scene is getting sharper and sharper as we sit here. And so I can just drag around. If I skip over some of these boxes really quick, you can change your controls. I'm in third person. I can do first person controls. And then I like this one. You can smooth the camera motion. So basically, your camera motions have this little bit of speed ramping when you let go. A few other things you can do here is that you can change uh, what you're seeing in your screen. So like right now, I am seeing the RGB colors, but you can up here change your render mode. So it says shade, and I want to see the ambient occlusion, and there you got your ambient occlusion, which kind of looks like an X-ray to me. It's pretty cool, but you can see all that data it's doing. And then there's just several other render modes. And if you use 1 through 0 on your keyboard, you can actually just flip through them without actually having to click on these. So you can see there's your normals, your positions, your depth, your distance. That one's kind of neat to see what's closer, what's further away. Distortion. Some of these show up better than others depending on how your scene is. What's cost the cost? So what's taking more of your computer to render that? And then slices, and you can look at a slice of your data, which is one way to look at it. And I'm not going to run through everything on the screen. Once you get it up and running, I'd say play with it yourself, see what looks good, see what you can learn from there. Um, some of this I'm not 100% sure what it does, so I just want to be fully transparent. Of I'm not an expert. I'm still learning some of that as well. But let's just look at the scene a little bit. So I did. It's almost done training. Everything is looking sharp. I have this pretty high resolution monitor, but if I bring it a little closer, you can get a little bit better look at it. It does really interesting things around water reflections, where you can see the reflections in the water. You end up with basically this full background that's fuzzy. Again, I didn't have a high megapixel camera because I downsampled it, so things in the background will definitely get fuzzy. But the interesting thing is, if I start to zoom out, you'll see the scene only looks good where I walked, and then you have all these basically light volumes all around. And I can show you how we're going to get rid of those real easily. So from here, I got this pretty well trained. You can save once you have it trained. So if you want to relaunch this, you don't have to do that again. You go down to snapshot, see here, and you can save your snapshot. I'm actually going to load my last snapshot because I thought it was trained pretty well. Just hit load, and it will load it up. And then I can stop training. So now I can see it kind of in that full resolution. And you can see that this was just after it rained, and you kind of get this reflections off that rainwater there on the bridge. I thought that was really neat. Um, I can also constrain what I'm seeing. So I have all these floaters, all this background. They have this crop size, and I can just globally crop the whole scene. So if I zoom out, you can see how that works. So there's just crop. And what it's doing is it's cropping it to a sphere, which we can also visualize. So in rendering options, or sorry, debug visualization, you have this cube in which is marching your lights through, and you want this cube to basically encompass your target, which is the bridge for me. And so it's basically cropping 2x the size of that cube out of the scene. So you get a little bit of the background, but not much. If you're doing an outdoor scene, you want all that context, you want 16. If you just want the subject, you can bring it all the way down to just one. And you can see here, it's in the cube, it's rendered, which is very interesting. And you can actually change the size of this cube in relative to the scene, which I will show you in the next steps for troubleshooting. And that's where I found that things got really good. I can also show my visualize my cameras. So again, this is great for seeing my walking path. Right, I jumped over the scene here. Let me crop this a little bit so you can see a little better. So basically, jumped over the bridge, made my way around. I got the inside of the bridge a little bit, and that's what you want to see. And you want this cube to be a majority inside your camera poses. And so that'll make sure that when you're looking from your camera level, everything is clear. And I find that these floaters tend to be around where the camera poses are. So if I take pictures from even further away from the bridge, I would have most likely less floaters on the inside versus the ones that are further out. So the further they are from these poses, you tend to get these floaters to crop out because everything's pretty clear. Even under the bridge, you can see I didn't get information, so it just kind of creates this kind of cloud look underneath it. So there's this, and this again, this rendered I think in 2 minutes without my show going here. There's a few other things you can do. You can change your camera. So let me actually get rid of this, um, expand this, and get rid of my camera poses so we can see this a little better. So we have visualize your cube and your cameras. Again, turn those off. You can actually resize this box all you want as well. I make it nice big so I can see it as I'm working here. You can use your mouse, the center button, to kind of change your center pivot, pull yourself around. But you can change the field of view of your camera, um, your depth of field, all sorts of things that you can do in post, which I think is really incredible. So you can get a really good scene by just changing all those. Um, and then again, you can turn on autofocus, how you want it to focus, things like that. Play around with those, and then just save your snapshot when you're happy with the training. Uh, this might crash my computer, but then I can also, if I crop this in a little bit further, I can actually turn it into a mesh. I know a lot of people are asking about mesh generation from a NeRF. Um, if I try to get a high resolution mesh, it's gonna crash this scene. But let me just hit mesh it, and there you go. You got yourself this mesh, and you can tell like I had this water reflections here, and so actually wasn't getting a good surface, but it did get more of a surface here where I captured more images. And this is a low resolution mesh. There's a lot of garbage. I also don't know how to get the colors on this mesh, but you can save this density as well. Um, but so there's that. There's render modes. You're I think there's maybe vertex colors. I have not played with the mesh too much because oh, here we go. Here's our colors. I haven't done the colors too much because or the meshes because um usually we're just going to use structure for motion, get a really dense point cloud, and do a traditional mesh on top of that. So this to me is not what it's for. I'm finding that the NeRFs are best for getting a view of a scene real fast from perspectives you couldn't get with just cameras. So as I think about with like a 360 camera, you have to jump from spot to spot to spot. I mean, those like those Matterport tours, but this would allow you literally to move freeform around an area if you have enough photos and see the whole entire area from whatever perspective you care about. So that's one thing that to me is fascinating. And imagine if then you rendered this out, you could have this in a game where instead of having to recreate a whole entire scene using CGI, you could just render a nerf of it and then explode the nerf. And as hardware gets more powerful, that's going to be definitely doable. Um, so let's jump into another example where I had a troubleshoot that got me a lot better results as well. So this is the bridge. Again, you can save this. I will show you next just two more things. How to change some variables to get a better looking output. This one turned out great, but if you're taking photos from just one side, you need to change some of your variables to get a better look. So I'm just going to close this and I'm going to do my workbench. So I think a lot of you may have found this live stream off this workbench that I had done. And so let me just start that one up. It's called tool bench. And it's going to load this tool bench. And oops. Okay. I need to go change some parameters. It's not what I was expecting. So if I go, what it was doing was just rendering just within a cube. So I can go change some of the parameters in that transform file that we created from Colmap. So if I go back to my data and I go to this tool bench, I have this transforms file. You can open it up. I suggest using Notepad++, and you will see that you have some parameters. Actually, I think I may have removed the parameter I wanted. So let's hear. Here we go. This Aab scale. This is the parameter I was looking for. So in the scopes at the top, you should have an AABB scale. And this will basically tell you how much within that cube is being rendered. And by default, when you export this, it'll be 16. So again, okay, let me re-render this tool bench at 16. Here we go. So you got this nice cloud, and my tool bench will come into focus pretty quickly here. You notice I got tons of floaters. It's not very clear. Uh, it's it's a lot of garbage. And if I look at my cube, you'll find that what I wanted was this tool bench, but the cube, I believe, is not quite there. So if I go to my debug visualization, you can see visualize cube, and it's actually in front of the tool bench. And so if I was to take this crop, it's just going to crop down everything that's in that cube, and that's not what I want. So what you can do is go to that transform file and change the size of the scene and change the where that cube is in relation to my cameras. So right now, if I visualize the cameras, you'll see that they were all taken in front of the tool bench. Let me expand this. And that cube is just kind of, it's actually kind of in it. I want to offset this cube here. And I want to shrink actually this. Actually, you don't make the cube bigger, but you can shrink the scene to fit in that cube. So let me show you how that's done. So again, I'm just going to close this because I don't want it. I do see this blue line. I know I need to move it in that direction. So I know on the XYZ transformation, which direction, and that's going to be the first variable. So let me just change that. So from here, I can just go back to my Notepad++. Oops. And I can add a couple variables. And so this is in their documentation. It's not as clear. You can add what's called scale. So if I go here, I can add scale, add it twice, scale, and I can add what is called an offset. So I'm just copy and pasting what I've played with in the past. So from here, the scale, I believe, is 0.33 by default on these. You can change that. So I made it point. Let's just make it. Let's go to let's just. I think I did point. Let's see what I had. I did 0.08. And so what you can do is you can basically do. Oops. You can basically take this scene and just scale it several times until you kind of get it what you feel is right. Let me just copy my scale out of here. And then your offset. So everything's offset by default 0.5. in all directions from your camera pose centroid, I offset at 1. So it's basically going to move that cube and it's going to scale the scene to fit that cube. So, and then the last thing is this AAB scale. It's 16. So it's going to capture things that really far out. I just want to capture what's, let's say, in the cube and then, or twice the size of the cube. So I can make this 2. And this might be kind of confusing, but if you play around with these parameters, you'll get an idea what it's doing. So I save that transform and let me just relaunch what I have. It looks like I may have made an error in my syntax. Let's see here. That again. Of course, when you're doing a live demo, things do not work. Let's see here. I'm just going to take this transform, which I had correct. Just going to go to my tool bench and replace that. So launch it. There we go. All right. So now it's launching, and notice there's not nearly as much floating going on. And it's basically going to train on my cube. And oh, I believe I left crop size as 1. So it's basically only going to let me go as large as that cube. So if I go to that transform file, wherever I put it here, you'll see AAB scales 1. I scaled the point. Basically, I scaled the scene and I offset the scene. So now if I go back here and turn on my visualization controls, go to rendering option, debug visuals, you'll see my unit cube is pretty much the scene here, which I wanted. And if I visualize my cameras, they are big. They're in front. So I offset it further, this cube further in front of those cameras a little bit. So now everything's just rendering right inside that cube perfectly. So you can play around with these parameters, but I had a lot of floaters that were in the front that are now gone because I have basically the area that I want trained that are in focus. So I'm actually going to take this. I already trained it. I'm going to load it again and everything will kind of snap focus. I'm going to stop training. And we're almost done with this demo here. I'm just going to show you now how I made these really cool fly arounds, which is really nice, is that they give you a tool to basically create camera visualizations. And all you do is you go to this and you collapse this whole viewer, and there's this camera path. And if I expand that, I can add a camera to the path based on my viewpoint. So right now, I just want to look at it like this. I can say add camera, and bam, it adds a camera. And then I can say zoom in, go like this. I can hit add cam. Now it adds another keyframe. So if anyone who's ever done animation will start to see these keyframes. So now I'm gonna, let's just kind of go up, add another camera, go down. So I'm just kind of like doing a swivel, add from cam, and you'll start to add these camera positions, and it will also add a curve. And I can actually, I believe, grab these cameras and move them using these transforms, and I can even cycle through my cameras here using these controls, and kind of change them. Maybe I want this one to get closer. And then if I want to basically get the camera view in the big screen, and see it and play it, I can do that, or I can look at it in this little preview. So if I go here, I'm gonna go through my camera path time and just scrub through it and see, oh, cool, that looks cool. I can have it autoplay, so I can get an idea without having to touch anything. And you can see that camera going from path to path. That's looking really cool. And if I hit read, now it's going to switch. So now I'm seeing it on the big screen. So like that. So now it's going to fly through that. And that looks really cool. And again, this screen is bigger than 1080p. So if I rendered this out as 1080p, it would be sharper like this image as well. Not quite that sharp, but it'd look really good. So as I'm going through, you notice these two are the same. So I can just go get more cameras if I want. But once you're happy with that, you can then go save this. You basically hit save and it becomes a basecam.json file. And then there's some pretty, again, this ByCloud AI has really good instructions. It took me a while to figure this part out. To get down here, how to render. If you have problems and you are missing PyEXR, message me. Try to help you out. That was missing because I had Windows or Python 3.10. Um, and it did some weird things and it wouldn't actually run. And so you just have to play with it in your path. But basically, they give you this nice script, this render script, where you basically say, here's the Python script, here's the scene, how many seconds do you want your animation to run, how many frames, name, and then your resolution. So to put that all together, it's pretty darn easy. And I would actually show you this live. You actually close this window here. I'd actually show you this live, but it actually takes a while to render this out. So if I go in here, oops, delete what I added there, but just go to my scripts I have here. I have rendered a video. So again, I made it easy on myself. So just gonna copy that because I know where everything is, and then go here. And then for basically data path, I'm going to change the seconds, render time, all of that, give it a name, and then it'll render that. And it will take a while. And your computer will pretty much need to just work on that while it trains. And then once it's done, it's not training, it's rendering. It's going to put all those frames together for you using FFmpeg, which again, make sure you have that installed and added to your path. I suggest using it for all sorts of things. And then you get a nice animation. So I can bring those up. I have no idea how well these will render in live, but if I go to Instant NGP, it'll put the render right here. So here's the bridge. And one odd thing I noticed is I told it to 60 frames per second for 60 seconds, and it did 2 minutes and 24 seconds of video. And I think what it did was it encoded it as a 30 FPS video and did 60 frames. So half the time. But then it add, or maybe it's 24 frames per second encoding. So basically, it moved extra slow. If you use video editing software, just know I actually have 60 frames in a 1 minute span, and then you can go speed it up and it'll all still be smooth. So there's that one. I just end up putting all my renders in an output. So again, I had this bent or this stump. The stump turned out really cool. You can see my shadow trace across because of the light. So be careful of that. If it's cloudy, you'll get a better view. Um, can move out, move back in, all sorts of fun things. Put music to it, uh, create all kinds of great visualizations. So let me just make sure I covered everything because I believe that's the end of my presentation here. But just kind of gives you an idea of NeRFs. If you guys want me to explore other implementations, I'd be happy to. I some people have pointed out um, that you can um, use different NeRFs out there that use less RAM, that take longer to train. I liked this one because I could find out really quickly how well it turned out. That bridge took me about 10 minutes to capture, took me about 5 minutes to get the camera poses on Colmap. It took about 2 minutes to render. And then I made the video animation another 5 minutes. So about 25 minutes, I had that animation fly around. And then it took another about hour and a half to render all that. So that took a while to render the images, but it went pretty quick. So again, I hope you guys found this valuable. Go through this instructions from the ByCloud AI fork. It is wonderful. Reach out to me if you have questions on LinkedIn. Um, I will be exploring this some more and just sharing in posts what I'm learning. I definitely am starting to find that the more pixels you have as input, the more RAM it takes. So it's not the number of photos, it's the number of pixels, I believe, combined. Because I've taken about 50 photos at 12 megapixels and it used almost all my RAM. And I've taken twice that with half the resolution photos and it took about the same amount of RAM. So I think it's a pixel limitation and not an actual um, number of photos. Although they do say it trains best from 50 to about 150 images in total. So there you guys have it. I hope this was helpful. How to run the NeRFs. Again, make sure you got Anaconda. Make sure you got Visual Studio 2019 and CUDA cores and all of that. Once you got that all, build it. And this is pretty darn easy. And you'll be able to watch this recording again on LinkedIn Live or on YouTube. everywhere I post it. I hope this is helpful. My next video, I probably won't do nerfs. I'll probably jump into something new, but I will also be going back to nerfs because there's several implementations I would also like to test on my hardware. Perhaps run it in a Docker environment, something different that's a little bit more interesting. So my goal is 45 minutes. I hope everyone found this interesting. Again, reach out. You can follow me on LinkedIn. I have lots of content like this. I like to have how to's. I'm working on actually a how to of basically capturing environments in 3D, basically a quick visual guide for photogrammetry. That'll be coming out soon, and that'll be very helpful as well for figuring out how to make your first nerfs. So, anyways, make some nerfs and share your results with me. I'll definitely comment and share them. And I'm excited to see what this whole technology goes and what people learn from it. And thanks for watching. And I'll see you in the next live stream.